Okay, so 6.3 matrix operations. It's on the worksheet there that I put on Google Slides. Okay, let's get going. These matrices, you can see they don't have the line there. We're just working with some basic principles of how they work with each other, adding, subtracting, multiplying, that kind of thing with them. So we're just getting our feet just a little bit wet here and trying to figure out just some basic ideas. We're not going to get deep into this. Okay, the first thing we need to worry about is how these are structured. These are structured, we call them, the order of the matrix is named by row by column. So we're looking at the rows. Rows go like this, like rows in a movie theater. Columns go like this, like columns on a building. And so the order of this matrix, what is the order of the matrix? You would count the rows first. So there are 2 rows by, and then the columns, 1, 2, 3. So this is a 2 by 3 matrix. 2 rows by 3. So we've got row 1, row 2, column 1, column 2, and column 3. This kind of structure here I'm going to put on here every single time. It won't matter until we get to the very end of the second half of the last problem we're going to do, the last couple problems we're going to do. I just want your brain used to rows and columns before we get to where we need it. Okay, and then it says find A sub 3, 2. A sub 3, 2. That means A is just the matrix itself, not a big deal. It's just the name we're giving it. 3, the first number in there. 3 means the third row, and 2 means the second column, because we go rows by columns. So we're looking in here for the third row, row 1, row 2, row 3. So A sub 3, 2 doesn't exist. Doesn't exist. There isn't such a thing. The other thing they want us to find is A sub 2, 3. So that would be in this matrix. We're looking for the second row. Rows always come first, get named first. We're looking for the second row, this row, and the third column, 1, 2, 3. So right there, A sub 2, 3 equals -5. Okay, let's do the same kind of thing with identifying what type of order this is. Remember, you're going rows, so 1, 2, 3. This is row 1, row 2, row 3. And then we've got column 1, column 2, column 3, and column 4. So rows, this is 3 by columns. There are 4 of them. And you certainly don't need to label this way. I just want you to get used to it for the last problem, the multiplying of matrices that we'll do. That'll be important. Okay, so they're asking you to find A sub 3, 2. That means we're looking for, in this matrix, we're looking for the third row, second column, the element that's in the third row, 1, 2, 3. So we're down here on the bottom. Second column, so that would be 2 right there. A sub 3, 2 is 2. And then A sub 2, 3. So in this matrix, we're looking for the second row. That's the middle row here. And the third element, third column, 1, 2, 3. That's a 4. So right here. Okay, any questions so far? Anything feels weird? Okay, let's move on. Finding the values of all the variables in the matrices. Okay, in order to play this game, they have to be the same order. That means they have to be the same size, the same structure. So this is a row 2 and column 1, so a 2 by 1, and so is this guy, with an equal sign between them. That means that if you will lay this matrix on top of this one, the corresponding positions belong to each other. So if I pick this little guy up and plop him on top, I'll have x equals 5, and I'll have 2 equals y, or y equals 2. It doesn't matter which side you put the variable on and which side you put the number on. So we've identified that x is a 5 and y is a 2. Because when you lay this little guy on top, like this little Lego, you plop him on top of that Lego, x corresponds to 5 and y corresponds to 2. Same thing's happening here. The orders have to be the same. So let's see, this is a row 2, row 1, row 2. That's a 2 by column 1, column 2. That's a 2 by 2 matrix. So is this one a 2 by 2 matrix. So we can play this equality game. They are equal. If you pick this guy up and flop him on top, the corresponding positions, the guy that's in row 1, column 1, x, would correspond to 14. So x is 14. Let's find y. Here's y. 3y equals 15. So you know y equals 5. Z is right here. Z equals 21. Corresponding position. This is row 2, column 1. This is row 2, column 1. And then 28 equals 28. There's no variable involved in there. They just asked us to find the values of the variables. So 14, 5, and 21. Super easy so far, right? It's going to continue to be this way. This is just falling off a log easy until we get to a tiny bit more challenging on multiplying of matrices at the very end. So, like I said, just relax and enjoy this easy peasy day. Okay, so A is the matrix 0, 11, 8, 1. Let's talk about how big it is. Take a second and think about the order of this matrix. It's got 2 rows and 2 columns, so it's a 2 by 2. Just going to put that up there. B is 2 rows and 2 columns, so it's a 2 by 2 matrix also. Okay. In order to add or subtract, the matrices have to be the same order, just like up here they had to match. They have to match here also. So to add, doesn't look much like add, but to add or subtract, matrices must be of the same order. These are both 2 by 2. If one of them had been a 2 by 2 and one of them had been a 2 by 3, we'd be stuck. We would not be able to add them together. We would not be able to subtract them. We can do this kind of work, but we'll get to that in a second. Okay, so let's find A plus B. Oh, no, don't come back later, Felicia. Welcome, welcome. No, you just, your car was running a little late, or you couldn't find a parking space, or you ran into somebody you needed to chat with. No big deal. Come on in. Do not leave. Order. That says order right there, Amanda. Is that what you're asking? You're welcome. And Felicia's husband, I hope this isn't disclosing too much, is a policeman. So you know that in their house, this is a stressful time too. I know this is a very stressful time hell, it's a stressful time for me watching TV. Last Wednesday, a week ago, right before my 2 o'clock class, I was watching some of the George Floyd trial. No, it's not George Floyd on trial. It's Derek Chauvin's trial. Sorry about that. Was watching the trial and listening to a 61-year-old man cry as he talked about trying to calm George Floyd down, and then on the stand the guy got so upset saying, "I've lost my mama too. I don't have a mama either." And I think how that's so detached from me on a personal level as a white woman. I mean, I get angry about this. Black people are scared about this. I mean, I was talking to my son. How many times did I warn him about what to do about when a cop approaches? He says once. Once I told him, the day he got his driver's license, this is what you do if a policeman is coming up behind you. I got a black friend, a woman, who she talks to her son every day. Every day. Every time he leaves, she talks to him about being careful. It is. And I don't know what the solution is. I mean, I know this is math class, has nothing to do with this, but it's a problem. Barack Obama talked about reimagining policing, reimagining, maybe looking at European countries and how they do it. I don't know. But it's not just stressful. I mean, it's extremely stressful for cops' families right now. And so I think about you, Felicia. I think about how difficult this time is for your family too. So, and for the students that, yeah, yeah. I mean, there's so many good ideas, so many good ideas. And Van Jones is one of my heroes. I love listening to him because he has such ideas I hadn't thought of. And what he talks about is we need to talk about this. We don't do enough talking. We just don't do enough talking about this. And I mean, we could spend 5 hours from now until afternoon, couldn't we, talking about this and never solve it and never move forward. I think just recognizing, I don't know, it's not good enough to not be racist. You have to be anti-racist. You have to tell your brother-in-law, that's not a funny joke anymore. You can't say that. You know, that kind of stuff. And that's hard to do. How to be an anti-racist. If you're interested in that, How to Be an Anti-Racist is a wonderful book by a man's name I can't remember how to pronounce. You can look it up. It's at the library. Okay, let's get back to this. Sorry about that, but welcome, Felicia. Yes, I will shut up about that and talk about this. To add or subtract these matrices, the matrices must be of the same order. Is that good for you, Chloe? And then Amanda had asked what the hell that word was anyway. Okay, good deal. Okay, let's move forward. Let's find A plus B. All that means is add the guys that are in like positions. So here comes A plus B. I'm going to build my little matrix. I know it's going to be a 2 by 2 because I'm adding this Lego to that Lego. So put that one on top. 0 plus 3 gives me a 3 in that upper left position in that row 1, column 1. In row 1, column 2, I'm adding 11 and 10, and I'm getting 21. Down here in this lower left, I'm adding 8 plus 12 and getting 20. And then in the lower right, I'm adding 1 plus 5. And that, my friends, that's it. That's all you got to do. You're done. Let's do A minus B. A minus B, because it's got a minus sign, is a little bit trickier. You've got to remember there's a minus sign there. All of these are positive numbers, so it's going to be a little bit easier than when we get complicated down here with negatives thrown in. But it's you know, I mean, you're a college algebra student. You can handle this. 0 minus 3. We're doing A minus B. Be careful. Just like regular addition and regular subtraction, order does not matter when we add. We could have added this one plus A, B plus A. We can change the order. Just like 3 plus 5 is the same thing as 5 plus 3. That's called commutative, but that doesn't occur with subtraction. So A minus B is different from B minus A. You got to be careful of the order when you're subtracting. So, but still, Legoland, you know, 0 minus 3 is a negative 3 in that row 1, column 1 position. In row 1, column 2, it's 11 minus 10, that's a 1. 8 minus 12 will work for row 2, column 1, that's negative 4. And then 1 minus 5 is also negative 4. And we're done. When we're multiplying a number, a single number, times a matrix, that's called scalar multiplication. S-C-A-L-A-R, scalar. Scalar, you can hear it also. It just means take negative 6 and multiply it times every element of A. So we won't be messing with B at all. So negative 6 times A, build the same structure for a 2 by 2. And then 0 times negative 6 is 0. 11 times negative 6 is negative 66. 8 times negative 6, and 1 times negative 6. Done. Nothing fancier than that. Okay, let's combine a couple of scalars. Let's do 2 times a, and then we'll add it to 3 times b. So first I'm going to do 2 times a. I can do that here. Mark a transition there. And then I will add 3 times b to that, and then we'll get our answer over here. Okay, let's do 2 times a first. So you're just doing 2 times each one of those elements. 2 is a scalar, times each, so 2 times 0, 2 times 11, 2 times 8, and 2 times 1. It's a 22 right there. Now let's go do 3 times b. I mean, this is super easy. If you're thinking you're not getting it, then you're making it too hard. This is so simple. 3 times b, just what it says. So 9, 30, and it doesn't matter the order. If you want to do this element next, 3 times 5 is 15, and then 3 times 12 is 36. Just put. Okay, so we've got 2 times a, and we got 3 times b, and this problem said to add them together. So add the little, row 1, column 1, 0 plus 9. Then jump around if you feel like it, but just make sure you get them all. I'm going to do row 1, column 2, 52. Row 2, column 1, 16 plus 36. And then 2 plus 15. And there's the answer for 2a plus 3b. Pretty simple. Let's do the exact same thing here. A plus b will do, then we'll do a minus b, then we'll do negative 2 times a, then we'll be doing 3a plus 5b. Let me give you a couple of minutes to do that on your own. We've got plenty of time, and I know it's so much better if you've got time to practice it. So let me give you about 4 minutes. I'll come back at 8:22. I'm not talking loose. I had turned my microphone off. I was just doing some, so I was giving you time. Sorry. So I'm going to turn my microphone off, and then I'm going to slowly go through these so that you can check yours as I'm doing mine. But thank you for making sure. I do appreciate that. You never know. Okay, A plus B, very little challenge there. My guess is you're doing fine there. A minus B, just be careful. -5 minus 10, so -15. 10 minus -2, which turns it into, of course, plus a plus. And then 13 minus 1 is 12. So there's A minus B. Remember, they both have to have the same order, 3 rows, 1 column, 3 by 1, 3 by 1. So they'll create 3 by 1s. Okay, so a scalar of multiplying A times -2, -5 times -2, 10 times -2, and then 13 times -2. Okay, let's do a couple of scalars and then add them together. So 3 times A, 3, 30, and 39. And then 5 times B, so 50. 5 times -2 is -10. And 5 times 1 is 5. And now we're going to add those two together. So I'm going to get 35, 20, and 44. Okay, nothing here is beyond your ability mathematically, and really the structure is very easy too. The process is very easy. Okay, any questions before we go to the next page? Okay. Oh, I do miss you all. I do miss the interesting personalities that would be more obvious if we were together. We'll get there. We'll get there. Okay. 5 and 6 are similar to each other in that they've got an equation that involves the matrices. Having tried these several different ways over the years, what I've discovered is first get this into x equals, get this into x equals, then we'll manipulate here. So I want to get x isolated. There's x. I want to move a to the other side. So I'm going to get x equals b minus a. If you want to put a first, you can, but it's got to be -a plus b. You've got to make sure that a has a negative on him. You know, this is just regular old variable kind of construction, but I think b minus a is the easiest. So x equals, I've got it isolated, that's my work right there, b minus a. Remember, it's not commutative. You can't just go 10 minus 4, stick a negative sign there. You've got to have b first, then minusing a. And I know that there might be a couple of you that could easily go 4 minus 10, 5 minus 5, but our brains don't go right to left easily. So I'm going to rewrite here. That's why I've got all this good space here. So let's put b here. Just rewrite it. And then let's subtract a from it. Let's get them in the right order so it'll be easier for us to do this. Okay. So, and let me even stick a minus sign in here so I don't forget it. So 4 minus 10, 6 minus 0, it doesn't matter the order. If you've gone over here to do 5 minus 5, that's great, no problem. 6 minus 0, this is row 2, right here is row 2, this is row 1. Just want you thinking about it. So we've got row 3, column 1, and column 2. And I'm going to do the corresponding element in A with it. So 6 minus 0, -4 minus -5. If that's just a bit too much for you to do out in the air, you know, write it out somewhere. Plus a plus, so we're getting a 1 there. 5 minus 11, and then 6 minus -6. Again, if that's a bit too much, there you go. Makes it much easier if you've written it by itself, or if you're just using your calculator, whatever. Okay, so we're getting this matrix. Notice that it's also a 3 by 2, row 1, row 2, row 3, column 1, and column 2. So in order to add them together or subtract them, they have to be of the same order, 3 by 2s, both of them. Okay, let's do the same thing here. Let's start on number 6 by getting x by itself. In order to get x isolated, I'm going to have to get rid of the 2, and I'm going to have to get rid of the negative a. This is just the same as if this said 3x minus 4 equals 7, something like that. This is the same structure as this. We're trying to get x by itself. So the first thing we would do would be move the 4 over, the thing that's attached by a plus or minus. That's the thing that's going to go first. So I'm going to move that over, and I'll have 2x equals b plus a, or a plus b. It doesn't matter. Probably it's easier for us because a plus b are written here, but it doesn't matter. Addition is commutative. The order doesn't matter for addition. So I think I'm going to change mine to a plus b just because that's alphabetical order and we're a little more used to that. So that's just like saying 3x equals 7 plus 4, or 11. And then still getting x by itself, we divide both sides by 3. That's what we're going to do here. Divide both sides by 2. So x equals a plus b, or if you've still got b plus a, doesn't matter, divided by 2. That's the work we've got to do to solve for x in number 6. So I think I can handle a plus b right here. Just adding these up, we've got a 3 by 2, a 3 by 2, so they're addable. So let's go ahead and add them first. And if you're skipping ahead of me, good, I'm glad. So in corresponding positions, I'll get a 12 there. Negative 7 plus negative 10 is negative 17. Negative 2 and negative 7, 4 and 8. 6 and negative 11. And then negative 5 and 1. Okay, that's a plus b. That's half our problem. Now we have to divide it by 2. So 12 divided by 2 is 6. Negative 17 divided by 2 is negative 17 over 2. Leave it improper. Reduce if you can, like we did here. We didn't leave it 12 over 2. We changed it to 6. So reduce if you can, but don't change it to a mixed number. It gets too confusing. Negative 9 over 2 will be in row 2, column 1. 12 divided by 2 comes out nicely. Negative 5 divided by 2. And then negative 4 divided by 2 is negative 2. So it gets a little messier there, but you're not going to have to do anything more with it, so you don't care. Okay. Ashish, does anybody have any more questions about that? Or is everybody good on that? Okay, we're good. Let's move on. Let's look at a times b and b times a. Now, you might say, hey, that's going to be the same thing, but not in the matrix world. Multiplying a matrix by a matrix is a little bit trickier. It's just by far trickier. You've got to look at to see if they're even compatible, and then doing the multiplication gets messier. But the fact that you know that this is row 1 and this is column 1 and column 2, that kind of thing, makes it much better for you. So I'm going to go away from this sheet of paper and work on regular paper as we get there, because I want to be able to take a lot of room. But let's look at the first things. Let's see. What order is this? This is 2 rows, 2 columns. So this is a 2 by 2. This is 2 rows and 2 columns. So this is a 2 by 2 also. They're both 2 by 2s. In order to do a times b, if we are going to do a times b, we've got to look at their sizes. So a times a is 2 times 2. B is 2 times 2. In order to be able to play this game, in order to be able to multiply them, the inside numbers, these 2 numbers, have to match. They have to be equal. They are equal. So we're going to be able to do AB, A times B. So you get the row, this is row by column, this is row by column. If the inside two numbers match, you're able to do the multiplication. So in order to do A times B, the inside numbers must match. Let's see, and that just escaped me, that little, hang on a second. Okay, I'm gonna never mind because this gets a little messier. We're gonna get there, Chloe. So the inside numbers of A, B have to match, and they do. So that means we can do this. We're going to be able to do multiplication of A times B. The outside numbers will indicate the result. So the outside numbers, let me grab them. This 2 by 2, that will tell us how big our resulting product of A times B will be. So when we do A times B, we're going to end up with a 2 by 2. And I am going to put 4 blanks there for my 2 by 2 when I do it, just because it's just so much easier to have a structure already in place. Okay, let's go over and play around. Hang on a second. Don't need that sheet anymore. Let's do this. Okay. A is 10, 5, 12, 3. And B is 0, negative 10, negative 7, 8. Okay, let's do A times B, which, as you know, because this is a 2 by 2 and this is a 2 by 2, the outsides will tell us how big our resulting matrix will be. So we are going to end up with 4 blanks, a 2 by 2, 2 rows, 2 columns. This is row 1, this is row 2. Let's label those on both. Row 2, column 1, and column 2. Okay, when we're finding the number that goes here, we are going to be multiplying. Okay, better than that. What position is this one in? This one is in the position of row 1, column 1. So we are going to be multiplying row 1 times column 1, because the position that this is in is row 1, column 1. That's what we're going to be multiplying times. The first guy's row 1, the second guy's column 1. Let's see what we're going to do there then. We're going to say 10 times 0, that's 0, and then scoot over on the row and down on the column. So it'll be 10 times 0, then plus scoot, 5 times negative 7. So it's going to be a 35 will go in that position. Okay, let's do that 3 more times. In order to find this number, that's made by row 1, column 2. That means we're going to be multiplying row 1 of the first matrix times column 2 of the second matrix. So we're going to be doing these 2 guys and then adding it to those 2 guys. Row 1, column 2. So 10 times negative 10 plus scoot, 5 times 8. So we're going to get negative 100 plus 40. So that'll give us a negative 60 right there. Okay, let's do this one. This one is made of the combination of row 2, column 1. So I am going to grab row 2 off of A, that's this row, and I'm going to multiply it times column 1 of the second matrix. So start on the left and start at the top, because that's how we do. We go left to right, we go top to bottom. So we've got 12 times 0 plus scoot. Go right, go down, 3 times -7. So I'm getting -21 for that position. And then finally, this position is created by row 2, column 2. So on the first matrix, I'm going to look at row 2. And on the second matrix, I'm going to look at column 2. So I'm going to go 12 times -10 plus scoot to the right, scoot down, 3 times 8. So I'm getting -120 plus 24, about 96, I think. And I didn't write that down, so if that's wrong, let me know. So this is the answer, 35, -60, -21, 96. Okay, let's do BA. Yes, thank you, -96, appreciate it. Okay, let's do BA. BA is going to give us something different. Let's check that out. If we're doing BA, that means B is going first, and that'll make a difference. It doesn't in regular multiplication. Let's see, let me get this. And here's A, this is B, this is A. We got 10, 5, 12, 3, and we're trying to do BA. Okay? Let's see if we can first. B is a 2 by 2. A is a 2 by 2. In order to play the game, those two have to match, and they do. That means we're going to be able to multiply B times A, and our answer will be a 2 by 2. So I'm going to set up a 2 by 2. I have found it is just easier to create this structure, put blanks in them. It doesn't matter so much when we're doing that adding and subtracting, that baby stuff that we did on the other side of the page. But this does matter to set up that structure. Okay, now first, AB, like if it were 3 times 5, that'd give you 15. We've just flipped them. 5 times 3, that gives you 15. So in regular multiplication, this regular multiplication does have the commutative power. The order does not matter. You can commute those. You can change their order, but without changing the answer. But in matrices, the order matters. So I'm going to put B first and then put A there. So row 1, row 2, column 1, column 2, same thing going on here. Row 1, row 2. And you decorate if you want to. If you don't need that reminder, don't do that. But I need that reminder for when I'm showing you how to do it. Okay, let's go after this piece right here. I'm going to give you a second to think about what it's going to be and maybe practice it, maybe see if you can get it. So go for it. Okay, I'm hoping you got -120. Let's look at how to do that. This guy is composed of row 1, column 1, row 1, column 1, like a multiplication table, you know, what intersects. So we're going to multiply row 1 times column 1, row 1 of the first matrix times column 1 of the second matrix. 0 times 10 plus, and then scoot over and down, -10 times 12. So that'll cancel out, and we get -120 in that position. Okay, see what you can do about row 1, column 2. Okay, so we're doing row 1. And we're doing column 2. So we need 0 times 5 plus scoot, negative 10 times 3. That'll cancel out. We'll get negative 30 in this position of row 1, column 2. Okay, how about this guy right here? Okay, row 2 is right here. Column 1 is right here. So let's start on the left and the top. So negative 7 times 10. And then scoot over and down 8 times 12. So we've got negative 70 there. And we've got 96, 696 there. So we get a positive 26 in that position. And then finally, got row 2, column 2. So row 2 is here, column 2 is here. So we've got negative 7 times 5. And then shift, 8 times 3. So we've got negative 35 and a positive 24. So we get negative 11 right there. So the matrix does not have the words in there, the letters in there. It's negative 120, negative 30, 26, and negative 11. Okay. Let's move down to the next one. Let's look at find AB and BA if possible. Same kind of game we're doing with number 8 as we did with number 7. Except that the matrices are of different sizes here. So let's see what we can do. Let's see. Let's first label them. So I've got row 1, row 2, and row 3. Column 1, column 2. Row 1, row 2, column 1, column 2. So what order is this one? That's what we need to determine first. So if we're trying to do AB, the order of A is 3 by 2. And the order of B, rows by columns, is 2 by 2. 2 rows by 2 columns. Remember, in order to play the game, the inside numbers have to match, and they do. So we can do A times B. That'll leave us with a 3 by 2 matrix. The result will be a 3 by 2 matrix. So what we're going to end up with here is 3 rows by 2 columns, 3 by 2. So this is what our structure will look like when we get finished with it. Okay, let's go ahead and do that. No, I need more room. Let's see, we're doing A times B. Let me start fresh. Okay, so A, B, and then the structure of what we're doing looks like that. And I know a couple of you are so comfortable with this. Maybe you've seen it before, or maybe your brain is just structured well. And others of you are just going to need to do exactly this each time and write in here and scribble some stuff. That's okay. This is as hard as it gets. This is the end of chapter 6 for us. Actually, that's not true. We have one more, but it doesn't feel like this at all. Okay, so let's go find this position. This is going to be row 1, column 1. I need to label them here too. column 1, column 2, and then row 1, row 2, column 1, column 2. Okay, so we're going after row 1 in the first matrix times column 1 in the second matrix. So we're row and then shift to the left and shift down. So it'll be 7 times 0 plus -1 times -4. So that'll just give us a 4. So that element right there will be a 4. Over here, this is composed of row 1, column 2. So we'll be using row 1 in A and column 2 in B. So it'll be 7 times 12 plus shift -1 times -11. So we're getting 84 plus 11, so 95 there. Okay, let's go down here and give you a couple minutes, or a minute, to see what you can do on this one. Okay, this is row 2, column 1. So I'm looking at row 2 from A and column 1 from B. So 0 times 0 plus shift 2 times -4. So that'll give us a -8 right there. How about here? So row 2 and column 2. 0 times 12, I'll just 0 out, and then scoot 2 times -11. So we get a -22 for that element. Okay, how about here? This is composed of row 3, column 1. Give you a minute. Row 3, column 1. So -3 times 0 plus shift 0 times -4. So that's just going to be a big fat old 0 there. And then finally, row 3 times column 2. So start on the left, which is the way we read, left to right. Start on the top, which is the way we work, top to bottom. So -3 times 12 plus shift 0 times -11. Fan of the 0, aren't you? So we get a -36 right there. Okay, so the answer then is 495, -8, -22, and 0, -36. That's the answer for A times B. Okay. The next thing they ask us to do is B times A, if possible. So let's look at that. Let's check B times A, if possible. So we're looking at B times A. We need to figure out how big B is. B is 2 by 2. And then times A A is 3 by 2. In order to play the game, the inner numbers have to match. They don't. So BA is just not possible. Not possible would be the answer. The inner numbers have to match in order for you to be able to play the game. Okay, so we are done. Let me grab our syllabus, not our syllabus, but our calendar. We're done with 6.3 right now. On Monday, we'll pick up 6.5 and a little bit of 8.1 and 8.2. This is the end of this course, and it ends easy. It does not end difficultly. Got till the end of the month. On Monday, we will do Monday, not next week, but the next week, we will do 8.3, and then Wednesday we'll do the review. And then you'll have typical of what we've been doing, Wednesday, Thursday, Friday to finish your test. And then the next week after that, on Monday and Wednesday, we will review. You know, I'll have the review. I'll have worksheets for you. I've got that. You don't have it yet, but I don't think you need it. If you want to look at what the review will be like, go out and look at my math lab for that review. You know, how they're similar. It's good enough. So we review on Monday and Wednesday. And then my plan is for Wednesday, Thursday, Friday of that week for you to take your final, and we'll be done. So I think that's it at this point. I am going to stop recording